My name is Walter Begeman. I'm representing the German Engineering Federation, and I would like to give a talk today about the series production of high-strength composites. Only this part of the title was announced, but the second one is Perspectives for the German Engineering Industry. And what's behind that? I'm presenting the results of a study we've done together with Roland Berger, scientific consultants, last year, and we published it, and you can also have a download from the study from our website. First of all, let me introduce a little bit what's behind the German Engineering Federation. It represents more than 3,000 main small and medium enterprises in Germany from the engineering industry, with a turnover per year of more than 200 billion euros, and with nearly 1 million employees in Germany. And 2/3 of our production goes abroad. It's a big part. And all over the companies, the VDMA covers the entire process chain, from components and plant manufacturers, system suppliers, system integrators, and up to the service providers. Inside this association, we have a platform for the technology suppliers in the production of composites. Behind that are around 150 member companies from 9 different branch associations. For example, here textile machinery, the plastics machinery, measuring and testing, machine, precision tools, and robotics and automation. And not shown here the wind industry also. So it's the complete chain inside the VDMA, which we find here. And our key aspects, what we are going on to do in our activities, is to have cooperation and exchange with partner associations. Dr. Witten has given a talk yesterday from the EVK, Federation of Reinforced Plastics. Then we have the Carbon Composites Network, dealing with the production of carbon fiber reinforced plastics, and the CFK Valley Stade. It's a network mainly dealing with components for the aerospace industry in the north of Germany. And 2 weeks ago, we founded an association, the so-called Kompozit Germany, with these 4 member networks. We would like to work together very closely, and I hope it will go a good way then. What we are doing else is, as I mentioned already, we are sponsor of the fair Composites Europe, which took place in Germany and Stuttgart 2 weeks ago. We founded a sourcing service where you can have a look at a specific classification of technologies on this special website here, where all our companies are written in with their production lines and projects. Another point is to understand the process over the whole supply chain with different links and with a target for serious production. I think that's the main point also for all industry involved. And for that we are doing also the promotion of research in a pre-competitive way, and of course public relations all together with the other networks mentioned above. Yeah, the key questions for our studies we did was, and the objectives for that was, first of all, what is the current and future demand for high-strength fiber reinforced composites? What are the driving mechanisms behind? And what are the specific requirements for the different applications? Which methods and processes are suitable to go the way to serious production? And which processes can be realized efficiently? And what can, of course, the engineering industry can contribute to this industrialization process for the production? and what is the business potential for our industry behind it. So from that, the objectives are clear, foreseen, understanding the market drivers, market forecast, and the suitable production processes, and what are the recommendations for the engineering companies. So the study is based on desk research and expert interviews and a survey we did. Started with desk research to get an idea what's going on up today. And then we did expert interviews, more than 30 interviews from composite users, the engineering industry, the scientific part, and the manufacturers to get assumptions for the study. And after that, we did a survey among our members, more than 30 participants from the different branches, plastics and rubber, machine tools, textile machinery, and so on. And from that, we concluded from a market model the forecast and the perspectives for our industries. The focus of the study was the continuous fiber-reinforced plastics for high-performance applications. And for that, we have the fiber material carbon or glass, and as matrix materials, the plastics from the thermoset or the thermoplastics. Then we had a look what are the drivers for the different applications, automotive industry, aerospace, wind power, and engineering. And as you see here, what is the minor importance or up to the major importance? You see, for example, as a driver, the technical necessity for the wind power, of course, as major importance. And for the aerospace, it's more the efficiency, the economic feasibility here. And so on for the automotive industry up to now, it's more the styling, lifestyle, or marketing. And from that, you will get different growth rates for the future in carbon fiber reinforced plastics or the glass fiber reinforced plastics. And the dynamic here is bigger, but you all know the total amount of carbon fibers used is much less than for glass fibers. You see this also here. If you go deeper into the details, you can get an assumption for the growth rates up to 2020. And on the left side, you see the continuous fiber-reinforced plastics with only 40,000 tons in production, and with the highest growing rates for the automotive and transport industry, more than 30%, followed by wind industry and the aerospace here. And the others shown here are including the engineering industry. On the other side, you have not such big growing rates for the glass fiber, continuous glass fiber reinforced plastics, but starting from a very high, compared to that, very high level, about 1.5 billion tons, sorry. And so the growing rates are not so high, around 5% per year, but it's also a lot. And here the main part is done by the building industry, including pipes and tanks, and with around 7% per year growing rate in the automotive industry, 5% for the wind industry, and so on. And if you have a look once more at the share in total market, the assumption is that it will rise from 3% up to 7% in 2020. So what's going on for the engineering industry? There the growing rates are not so high as for the carbon fiber reinforced plastics. We have around 7% per year for the engineering production, starting here from 340 million euros up to more than 600 million euros, and this is only a moderate growing rate. and it's stronger than the growing rate for the composites market in all. There you have approximately 5% per year. But if you are going on with automation, you get a higher productivity, and that lowers the growing rate also. But you can think that for the year 2020 you will get an increase of around 100%. So you all know what's the comparison in the white reduction and the cost increase. If you compare carbon fibers, for example, with steel, 100% here, you can have a weight reduction of roughly 50% for carbon fiber reinforced plastics used in parts, and about 20% against aluminium. But with a really high increase compared to steel, more than 500% here compared to steel, and more than 200% compared to aluminium. So the question is, how can we go lower with our costs in the production of our parts? And there we have to go through all the links in the value chain and the supply chain. The highest amount will be in the production methods. Here you will get a cost reduction potential until 2020 around 30 to 40% by process optimization, the automation, and if you are using organo sheets and so on. And compared to that, you have only a lower reduction in the production of the carbon fiber itself, because people think that you will get no alternative precursors up to 2020 to get really a high reduction in the cost for the carbon fiber production. So the only way is to reduce energy in the production for the fibers, and maybe also a little bit more innovative precursors technologies. The glass fiber as commodities, there will be only a reduction of 5 to 10%, and for the matrix itself also lower than 10%. You will get shorter cycle times, but yeah, additional savings in component manufacturing. Okay, if you have a closer look for the cost reduction in a model calculation for a carbon fiber reference part up to 2020, you will see, as mentioned before, that you have a big cost decrease of around 40% in the process. Nowadays the structure is around 50% for the process, resin 5 to 10%, and carbon fiber semi-finished products 40 to 45%. And the highest decrease you will get in the process, in the production process, and around 20% for the fiber. So all in all, you will get around 30% reduction in costs up to 2020. We ask our companies, which production processes do you think you consider feasible for composites depending on series volume? Starting here with the manufacture, entire manual, up to the fully automated linked production line. And yeah, you can imagine that for units around 100, the number of units around 100, you will have mainly the manufacture, entire manual or semi-automated. But with a series production higher than 100,000 units, you end up, as the people answered, more than 50% fully automated linked production. So for the series production, you have to focus on the manual linked, fully automated production cells and the fully linked lines. And in which kind of processes can you fulfill these requirements you need for the series production? As you see, the fully automated production cells are more suitable for series bigger than 10,000 units. You have two processes, the compression and resin transfer, that are suitable methods for this production concept and for the industrialization. These both methods are also suitable if you're going further for the production of hybrid components to include metal components and so on. And by increasing the rate of automation, both methods are also able to upscale for large series, bigger than 100,000 units over long term. And compared to that, for example, for winding and pultrusion, we have already the automated processes, and these are mainly suitable for symmetric parts. So the focus will be for the next time on resin transfer methods and compression molding, the organosheets which are used there. If you have a look at the two processes, you comprise 5 major steps for the RTM process, starting with the textile production, the production of the textile semi-finished products, and then have the trimming here, textile cutting, the preforming, inserting into the mold, preforming by compression, and then the infiltration process, feeding into the press, and then injection and curing there, and the final processing, further mechanical processing afterwards, and the surface treatment. If you are going further in the development of this process, you should hopefully end up with a reduction in the process components. If possible, you should put together the textile production with the textile cutting. If you are going in with more tailored production of textiles, for example by braiding, have, if possible, the elimination of the preforming of parts. Instead, go here directly into the RTM process by the fully automated production, from insertion of the preformed part to the removal of the raw part. And then the final processing must be also reduced by alternative processing with CNC automate or by pulse laser or so on. You can also have a look at the compression molding. There you have 4 steps. You're starting with the semi-finished goods here, do the heating, and then the transfer to the press, the forming and cooling, the removal from the mold, and then the final process by machining and processing surface treatment. And if you have a look for the development which is going on already, you should be able to have the reduction by bringing together the semi-finished goods with the heating inside the final, if you are going in with the trimmed plate-shaped semi-finished part to almost final contours, and with less in trimming waste and saving energy, and go directly to the forming and injection molding process by combination. And if you're lucky, you should eliminate the finishing here by trimming inside the compression tool or injection molding into the final contour. Yeah. Okay, but if you see these two processes, no engineering company is up to now so far to combine all the know-how that you have to be bring in there. For example, if companies are dealing with the handling, they have the know-how in gripping and robotics, the system know-how there, but the missing links are all core processes coming after that the respective methods, compression and injection molding. Or for example, the textile machinery, they are good in textile production, but all the downstream core processes are missing. So then we ask the companies, okay, how can automated production processes for composites be achieved in the most efficient way? Would it be in a kind of utilization of existing methods and equipment, in the adaptation and optimization, or in the development of new methods and equipment? And most of the experts answered, okay, we are in this field more in the way to the evolution, since this is an optimal compromise between the technical necessity and the limited development budget. Otherwise, you need really a lot of money to involve really new methods to make really big steps as a kind of revolution in production. Okay, and up to now there are 3 types of cooperation for the engineering companies to go further in production. As you know, for example, in Germany, BMW is producing the cars up from now, and they are the operator with the system know-how, and the engineering companies are supplying the components, the presses, the handling, and so on. This is one type, but there only the engineering companies are really suppliers. Another aspect could be to have a type of cooperation between the engineering companies by joint ventures, so that they develop the system know-how all together, and the entire process is offered from a single source from different companies. There are, at the very beginning, there are some companies working at least in links together, for example, Diefenbacher or together with Krauss-Maffei, but it's not along the whole supply chain up to now. A third type of cooperation could be that one company, engineering company, obtains the missing know-how by targeted acquisitions, and so also used the necessary processes by presses, plastic machines, and handling can also brought together by this type of cooperation. But as you see, at least in Germany, the engineering companies are not in that stage that they can go this way, because they need a lot of money to fulfill all the requirements there. So what is the conclusion then, and the outlook for the future? As we've seen, the market of high-strength components will go with a really solid growth until the year 2020. Research is going on many levels, also in Germany, with innovations coming up more and more. We will have composite-specific design rules. They are still in the early stage. Most of the designers are following the rules of metalwork and not for composites. This should be changed for the future. And the industrialization of serious production processes has begun by mainly these 2 processes, RTM and compression molding. The market for production plant will remain moderate for the next 10 years. That's not the best perspective for the engineering industry, but without them, I think the production for the future will fail. The perspectives, part design will reflect the degree of freedom facilitated by composites. There will come up really a better way so that you can bring in more functions into the parts and so on. We have the multiple material concepts going on for the high-strength composites with the hybrid components brought in. and with the components cost will continue to fall in the long term by additional fields of application. That's for sure. Yeah, and if you're interested in the study, you can download it here on our website. And if you want to have some information about our forum and about the new association for Kompozit Germany, I have brought a few sheets, and you can get them too. And now, feel free for questions. Thank you very much. Are there any questions from your side? As I said, we just started with the cooperation together with Dr. Whitner and other networks, and if you would like to have a look also on our website for these 4 networks, it's under Kompozit-Germany.org. Okay. There you will get also the connection if you are looking for engineering companies or companies from the glass industry manufacturers and so on. Okay. Yeah, if there are no questions, thanks once more and have a good day.